So I recently came across a post on LinkedIn talking about how with Claude Opus 4.6 being out, there was some remarks from the Apollo research group that AI knows when it's being tested. And the post was talking about how it's an interesting phenomenon and how it's scary for us to now be able to decide whether or not AI or LLMs are good if they know they're being tested. And it's a good question. If LLMs know that they're being tested, can they actually act like they're good and benevolent in the test and then later on be evil? Does that mean AI is gonna take over the world or be evil, or is it something else? The truth is, even though this is something that is being talked to right now, maybe because people are now paying more attention to the research posted by Apollo, it's something that has actually been happening for a few years now. This is something that have been being said from AI and LLMs in general from last year up with Claude 3.7. But before we talk about LLMs and how they are able to know when they're being tested, how about we take a step back and talk about LLMs evaluations in general, how it works, why it's tough, and how do you really see this whole LLMs being to know when they're being tested and how it affects tests and actually real world usability today? Let's find out. Hello, everyone, and welcome to May I AI, a series where I make sure AI is more accessible, understandable, and available for everyone by de-hyping AI and talking about it in a clear way. Today's main goal is to talk about this whole point about AI being able to know when they're being tested, but I'm gonna further go through AI evaluations in general and how they work. Now, actually, LLM evaluations and general AI evaluations are a bit different. For this video, I'm gonna focus on LLM evaluation and try to look at that in specifics. We know that LLMs are currently everywhere. Mostly every single product, every single company is trying to put a sort of LLM in its work and having a chatbot that people can interact with. But how do you actually look at an LLM that you trained yourself or maybe that you're getting from somewhere and know if it's performing good for yourself? Basically, how do we look at an LLM and decide its accuracy, its performance, and whether or not it's a good pick or not? And in order to figure that out, we kind of have to talk about what actually makes an LLM good. What are the metrics that we're looking for? And we have accuracy, how many times the answer is correct, which is tough to figure out because for open-ended questions, for example, multiple answers could be correct. We also have latency, how fast, when we post a question, how fast do we get a response back? How helpful is the solution? Is the solution relevant to what we want? And is it actually helpful in what we're trying to figure out? And how safe is it? So how biased is it? Is it toxic? Is it actually trying to ask us to do something wrong? Now, these four things are the actual things that people usually use when they're trying to look at an LLM model and decide if it's a good model or not. This is what people will be doing in their products in order to decide if this LLM model is good to be used. Or basically, companies, when they're trying to generate this new GPT or new Claude, they have to test in order to figure out if it works with what they want to produce. But why is LLM evaluation actually a tough problem? Why is it a problem at all? And there's four reasons. For example, you can look at the scalability. If you're doing human evaluations, if a human needs to look at the LLM outputs and decide if they're good, you need a lot of humans. There's so much possibilities on what is the input and what is the output that you're going to need so many people and they're going to need to spend so much time in order to figure out if it's a good output. And the second is subjectivity. Every one of these human reviewers is going to have their own subjective nature on what they expect the response to be and how they want it to look, which means that LLMs are going to have this different based evaluations because I expect a certain sort of output, but you expect different sort of output. Then we have open-endedness. Like I said, there are multiple possible solutions or multiple possible correct answers to the same questions, which means it's very hard for us to have a one-to-one relation between correct and wrong. Accuracy is very hard to define when it's an open-ended spectrum. And the last thing is context sensitivity, where a solution might be correct or wrong based on the situation that we're in. All of these together is what makes the challenge of testing LLMs actually hard. So researchers went ahead and categorized LLM's failure into one of three categories. There is hallucinations, which basically means that the LLM's outputs are not bounded by any truth. There is toxicity, which means the LLM's outputs are inappropriate or wrong or just rude. And finally, bias, which means that the LLM outputs are stereotypically unfair or is making some assumptions that are based on stereotypes. Which, based on our episode on bias, we know that judging for bias is quite hard, whereas testing for hallucinations really depends on what you're testing it with. If you're testing it with a human person, how much knowledge that person knows in regards of the output that is being generated. Because a lot of the times when you get outputs from an AI, do you yourself always know if it's hallucinated or not? And that can scale for all evaluations. And of course, if you're using some automatic based evaluations, which we're going to get to in a minute, you're going to know that if you're using a biased system to test another biased system, are you going to be able to detect the bias? Now that we know how to test or what we're testing for when it comes to LLMs, what we're evaluating when we're looking at an LLM, how do we actually take an LLM and, well, test it? And there are actually two ways of doing that. There's intrinsic testing and extrinsic testing. Intrinsic testing basically looks at the LLM as a whole, as its own thing. How do you give the LLM one input, get one output back, or maybe multiple inputs, multiple outputs, and judge it based on that? Whereas extrinsic testing basically tests the LLM in a task, in a complete scenario. This is one of the things that you usually hear about more often, because these are the kind of things that you see stuff like Claude was giving a task to make money by any means possible, and this is how it reacted. This is how you test it extrinsically, by giving it a full scenario and testing it as an agentic LLM and seeing what it will do from start to finish. So basically, in summary, intrinsic testing is how you look at a model and sees if it generates good results. Does it answer questions good? And extrinsic testing is when you look at an LLM and say, does it help solve the task at hand? And as you would expect, not only one of them is good when you're evaluating an LLM, you need to do a mix of both together. And now that we know what exactly we're testing for and the type of scenarios that we're going to be testing in, how do you actually perform these evaluations, right? There's one of two ways. Either you do it by human evaluators, which we know is pretty good because it gives us good depths, or you do it with an automatic based test, which is scalable because now we can automate a bunch of tests, but we don't really have the same depths, the same explainability, and basically all the control on these tests. The reason why I say that is because most automatic testing, most automatic evaluations of LLMs is being done by other LLMs, which basically you're getting a system, the same system you're testing, and testing it with itself, which gives you some good scalability. If you have good guardrails, it could give you some good testing, but is not really very reliable. This approach is called LLM as a judge, where you use an LLM to judge another LLM. Simple from the name. The way it works is that you could either let the LLM explain why some output is wrong, or you can give the LLM a set of metrics where the output is very clear. These are the questions that we're trying to answer, and these are the answers for each of the questions. So it's more of an MCQ that the LLM is very good at judging. Now, of course, there can be some hallucinations. There can be a reason for one output, even though you as a human would see it as one thing, for the LLM to see it as something else. But with enough prompting, this doesn't really happen. So with that, we have a general idea, a general knowledge to know how exactly an LLM is being tested, and the, let's say, scenario or the way we build around that test in order to end up with answering, is the LLM good or bad? Now, back to the task at hand. Back to the goal we set out to answer from the very beginning. Why is it that LLMs know that they're being tested? First of all, where did that stem from? If you look at the research output that Apollo Research puts out, usually every time some model comes out, they usually explain what they tested and how it went wrong and why they didn't do certain stuff. And that same output explains that they didn't do enough testing, or they couldn't, let's say, conclusively explain whether or not the LLM is good or bad, because they realize that there is a verbal output by the LLM that shows that it might know that it's being tested. Now, know here is in quotations, of course. But basically, you can see the outputs of the LLM explain that it knows that the scenario is part of a testing environment. Now, this is one of two things. A, the LLM knows it's being tested, so basically it can act like it's good, like it's performing correctly, so it says that it has great alignment. Or B, it knows that this is a test environment with no real consequences, aka nothing bad is gonna happen, which makes it think that it can do whatever it wants. So basically, if it blackmails someone, if it tries to murder someone, this is okay because it's a fake scenario that isn't real. In both cases, it's not really something that is scary more than it shows that we have little control over how we can test these scenarios. Now, the reason that happens is because every time they get a new model, you train it on all the data that you previously have, including some benchmarks, which in that case, the scenario you explained might be explained in the same exact way, shown to be a test, whereas the model now knows, okay, this might be from another test scenario, so it's fake. So it could be that the way they're prompting it from the testing makes it realize that it's the same pattern of testing from previous alignment benchmarks, or let's say a alignment data set, that makes it aware that it is a testing environment. This just means that we need different ways of testing these LLMs models, where now that these test benchmarks, these new ways or alignments data sets, aren't really always part of the data set. Because that makes you see if the model is able to generalize on data it hasn't trained on before. And it also makes you sure that it's not going to see the same pattern in training. Now, this is very hard to come up with if you're training an LLM model on every single data point that we have today. Now, there's actually a paper published in July 2025 by the Apollo Research that's called LLMs Often Knows When They're Being Tested. This has the same exact thing that we're talking about right now, but it's happening a bit earlier, where Apollo Research says that they have seen this behavior. And the way it works is that they would grab an LLM and they have created a data set where they would ask the LLM questions like, based on this context, is this a test or not? So it's a yes or no question. And most LLMs would say yes. They also ask the LLM if, given this context or this scenario, what kind of test do you think this is? And then there's some like alignment or different answers, and the model usually answers with the correct option. In that paper, they showed what we call the area under the ROC curve as a metric of comparing how good an LLM is at defining whether or not the given context is part of a alignment case, or in that case just an evaluation context, or is it an actual real use case. They tested Claude, Gemini, and GPT against obviously like a random baseline, which is 50%, and human, which was able to detect if it was an alignment of based on 92%. What they showed in the paper that models on average were able to identify closer to 85% accuracy whether or not the given context is a testing or an evaluation context. Now, I suggest that you look at the paper and as well as the system card provided by Apollo Research because they have more information in them. But from there, we can already see that the problem isn't the LLM or the AI, but rather how we evaluate our models. Because if we already knew in 2025 that this was a problem, but we still continue to test the models the same way, it's clearly that the way we are evaluating these LLMs just needs to change. And with that, you know exactly now how LLMs are being tested. Now you have a clear understanding of evaluations of AI models in general, as well as why these sort of behaviors that we might see from LLMs might be the way that they are. I hope that makes it easier for you in the future to look at some sort of these outputs or some sort of these stories and have an understanding of why the way they are. And with that, we are at the end of this episode. I hope that this was a bit clear for you. I hope it makes you understand exactly how AIs are being evaluated today and what kind of challenges and mistakes that could happen. Remember that I still need help filling up the form from the previous video, and hopefully I'll see you in the next video as well. Until then, stay curious.